Question 3.43. 4-point charges are arranged in a square with side length 2a, where a equals 2.70 centimeter. The charges have the same magnitude, 1.50 nanocoulomb. 3 of them are positive and 1 is negative, as shown in the figure. What is the value of the electric potential generated by these 4-point charges at point P equals 0, 0, C, where C equals 4.10 centimeter? So here in this question, you have 4-point charges placed at each corner of a square, and the magnitude of charge on each of them is Q equals 1.50 nanocoulomb, which is 1.50 times 10 to the power negative 9 coulomb. 3 of these charges are positive, and I will call them charge 1, 2, and 3. And the fourth charge is negative. The length of the square is 2a, where a is equal to 2.70 centimeter, which we can write as 0.027 meter. And we need to find what is the electric potential at a point P because of these 4 charges, where P is along the z-axis at a distance c from the origin, where c is equal to 4.10 centimeter, that is equal to 0.0410 meter. So before we solve for electric potential, let us first find what are the distances of these charges from point P. So as you can see from figure, the 4-point charges which are placed at each corner of a square are equidistant from point P. And we can write their distances from point P to be r. We can find the value of r as square root x squared plus y squared plus z squared, where these values are x, y, and z component of r. Now, as you can see from the figure, the origin is at the center of the square with side 2a, and the x and y component of each charge is either a or negative a. And when you take square of them, they both become a squared, and negative a squared is also a squared. So here x and y component will be a squared plus a squared. So we get r equals square root x squared will be a squared, y squared will be a squared, and their distance along z-axis is c, so plus c squared. That gives me the value of r as square root 2a squared plus c squared. Now let's find potential at point P. We know that electric potential V is a scalar quantity. So if I want to find electric potential at point P because of these 4 charges, I need to add potential due to each of them at point P. So we get V equals V1 plus V2 plus V3 plus V4, which is equal to KQ1 over R plus KQ2 over R plus KQ3 over R plus KQ4 over R. That is equal to, now K is common in all the terms here, as well as the distance R is the same. So we write this as square root 2a squared plus c squared. Then we substitute the values of Q. Q1, Q2, Q3 are positive Q. So we write Q plus Q plus Q. Q4 is negative Q. And when you solve this, you get the potential to be equal to 2kq over square root 2a squared plus c squared. Now substitute to solve for V. 2 times k is 9 times 10 to the power 9. Q here is 1.50 nanocoulomb, so times 10 to the power negative 9 over square root 2 times a squared. A is 0.027 squared plus c squared. C is 0.041 squared. And when you solve this, you get potential at point P because of the 4 charges to be equal to 481.9 volt.